chord. So I'll answer this question in a minute, but I want to show how to draw piecewise functions like this in Desmos. All right, so I like function notation, so I'm going to call mine f of x. And to do a piecewise function, it's kind of like the way we draw them on papers. We use a big tall curly bracket, but I don't have big tall curly brackets. I just have the regular curly bracket. And what you do is you first say what x values to use for part of the graph. So like this part of the graph right here, I'm using any x value that's less than 1. So first thing I do is I tell Desmos in here to use x values that are less than -1. And then it is a colon, and then you give it the function. So I'm guessing that function right there would be something like slope was about 1/3, and it passed through the point -1, so x plus 1, and then y was -1, so -1. So that's my estimate of what I saw on that screen. It's not exactly the same, but it's close. And then if you have other parts of the function, then you put a comma and then say, what's the next group of x values? So next on that one, I get to use -1 for this one. So for that one, I would say, comma, x is greater than or equal to -1, colon, and that slope looked to be about -3. And what was that? X value was -1 and y was 3. So x plus 1 is going to shift me over, and then I want to shift that up to 3. So that's my estimate of what I saw there. And I guess that's not, it's more like -2 for a slope. So it's similar, but not exactly the same. And I have this jump here. Now, Desmos isn't showing me the open circle here and the closed circle there. The open circle is like a less than, but not equal to. And the closed circle is in this case, a greater than or equal to. It's the or equal to part that lets you fill in the dot here, but not there. So that would be how to graph that. And if you have more pieces, you just keep going comma, comma. So let's see. I did a step function earlier. Let's do a function that steps. So let's make a function called g of x, and it's going to be in pieces. And let's say its domain, oops, wrong parentheses. I'm going to go from, say, 0 to 1 for x. So I make a compound inequality for that. So I'm going to say 0 is where I start, and I'm going to put a less than or equal to. So x can be greater than or equal to 0, right? So I'm starting at 0 and I'm moving on, but I want to stop x at 1, but not let it be 1. So x has to be less than 1. And in that case, I'm going to say y is just equal to 1. And then, oh no, I need a colon to say what y is. So y is 1. And then comma for the next piece. For the next piece, I'm going to start at 1, and x is going to be, I'm going to put a less than or equal to, and then an x. So reading from the variable, this says x is going to be greater than or equal to 1. But then I want to stop x at 2. And then maybe there, colon, I'll let y equal 3. We'll jump way up there. Comma. And then here, I'll just let it keep going for x that is greater than or equal to 2, where I left off, colon, I'm going to let y equal maybe 1/2 x. So it picks up at an angle like that. So you can keep making pieces as long as you want, and it's always the group of x values you want, and then the function value for that. So if I wrote that down in my notebook, that function g of x would look like this. And I'm going to make a pretty tall curly bracket because I have 3 pieces to define. So when I write it on paper, usually we state what the y is equal to. So y is equal to 1 if x is between 0 and 1, including 0, not including 1. And then I let y equal 3 if x was between 1 and 2, including 1, not including 2. And then I let y equal 1/2 x if x was greater than or equal to 2. So I made my domain here. If you put all that together, x is greater than or equal to 0. So I've made definitions for every number from 0 to the right forever using those pieces there. And we can make Desmos graph that using the curly bracket. And then it's the part of the domain colon, what should y equal? Part of the domain colon, what should y equal? Next part of the domain colon, what should y equal? Piecewise functions. All right, let's go back to this question right here. So this function asked me a few questions, and those are the questions about continuity, the 3 rules for continuity. Determine which one of the following explains why continuity is violated. So does f of a have a value? And the answer is my a is -1 here. And yeah, it's 3. So this one's okay. Does the limit as x approaches a of f of x not exist? And the limit, since it doesn't mention the left or the right side, the limit does not exist. So that's my reason right there. And I can't even get to this rule right here because the limit doesn't exist. I can't talk about if they're equal because there ain't no limit. So that would be the reason I'm violating continuity here, that what's happening on the left side of x equals -1 does not match what's happening on the right side of x equals -1 there. All right, fun with piecewise functions. Woo.